first aspect of the paper is to introduce the Raman effect in contrast to the X-ray scattering of unmodified type, which was already observed by Compton. This particular effect is called as a Compton effect, and this is generally observed for free electrons. So what Raman is trying to do is to ask whether one can observe this effect in optical wavelength of the electromagnetic radiation, and to ask whether that particular effect is also observed in the optical frequency of the electromagnetic spectrum. Now, he mentions that it accordingly becomes necessary to test whether this is actually the case, whether this analogy from the Compton scattering to the optical frequency can also be associated with the something called as inelastic scattering of light. So what they mention is the experiments that Raman and Krishnans have confirmed this particular anticipation and shows that in every case in which light is scattered by molecules in dust-free liquids or gases, the diffuse radiation of the ordinary kind, having the same wavelength as the incident beam, is accompanied by a modified scattered radiation of degraded frequency. Degraded frequency means reduced frequency. So once you incident light onto an object, in this particular case a liquid or a vapor, the light gets scattered. The scattered light can now have the same energy or the modified energy. It is the modified energy which they are trying to tell that it is a new type of secondary radiation. The secondary radiation essentially is coming from the interaction of light from the scattering fluid in this particular case, and the light which is emerging out actually has wavelength which is supposed to be different from the incident wavelength, and that's where the secondary radiation and the modified radiation is coming into picture. Going forward, they give all the details about the experimental protocol they have used, at least in a crisp way. They mention that they use sunlight. Remember, this is an age where lasers were not available, so they had to perform an experiment with sufficiently bright light, which is the brightest source of light you can get. That is sunlight, especially if you are in India. So what they did was actually took sunlight and focused it very, very crisply onto the liquid sample and then looked at the scattered radiation. They also used a technique called as complementary filters, which ensured that the light what they were capturing was indeed the so-called secondary radiation, which had the modified frequency. So the last paragraph of this, the last few lines of this paragraph tells it very succinctly. The reappearance of the track when the yellow filter is transferred to a place between the sample and the observer's eye is proof of the existence of the modified scattered radiation. Spectroscopic confirmation is also available. So they are mentioning that it is not only the visual observation, but also there is a spectral observation of this particular phenomena, which confirms the phenomena and gives a very nice analogy to the Compton scattering. The third paragraph mentions how they took elaborate data specifically for 60 different samples of common liquids were performed. So it's a laborious kind of process to confirm this in a systematic way. And the effect is scattering and not fluorescence. And this is an important kind of differentiation one has to make, because fluorescence is also a phenomena which will give rise to the decrease in the frequency. But if you have to differentiate between the decrease in the frequency because of the Raman scattering effect and differentiate it from the fluorescence effect. So how do you do that? They use polarization of the scattered light as a mechanism through which they are able to extract this particular observation. The investigation is naturally much more difficult, as they clearly mention, in the case of gases and vapors, obviously because the real low signal to noise ratio what you get from such kind of scattering effects. So in that way, they mention that this whole effect is repeatable, and it essentially demonstrates the modified scattering, and both on liquids and on vapors. Please remember that there's also a very interesting question of whether Raman and Krishnan were the only two people who were observing the effect. No, there were some Russian scientists who are also doing this particular experiment, but on some kind of crystals. In a separate video, I'm going to hopefully discuss that particular observation and contrast that to some of the experiments which Raman and Krishnan were performing.